In chapter 4, we're going to start looking at Newton's laws, and we're going to begin by looking at forces. So, first of all, to define a force, it's either a push or a pull on something. Maybe it's the pull of gravity downward on an object towards the earth. Maybe it's you pushing an object, but a force is going to be a push or pull, and that's going to be measured in newtons. Often we measure those in pounds when we weigh something. Weight is really looking at the force of gravity on an object. So newtons or pounds, but in physics and science in general, we're going to use newtons to be our unit. We will also include arrows to indicate the direction of the force. So when we're thinking about gravity, if gravity is pulling things down towards the earth, we would have a downward arrow. If something is being thrown upward, the force of gravity is still downward. So even though the object's moving up, the force would be pointed down. So if we were to look at this example, an airplane, we've got 4 different forces working on that. Obviously, gravity's pulling it down. Lift of the air is forcing that up. Then the thrust of the engine would be a force forwards. And then air drag would be towards the back. And so we have to look at, are these forces balanced out? So if the plane isn't moving up or down, then the lift and the gravity would be the same. If gravity is more than the lift, then the plane's going to be falling downward. So we have to look at all of the forces acting on an object, and then we also have to see which force is more than the other to know which way the object would be moving. Mass is a familiar term, something we've talked about before. So amount of matter, amount of stuff that an object is made of. And remember that kilogram is the unit for mass, and this is a scalar quantity because there's no direction involved. So if we have an object that's falling, the force on that object is going to be gravity, and it's going to be downward. And if we're looking at weight, we would have to know the mass of the object and the gravity. So here we've got a man that's lifting 1 kilogram weights. And in the first picture, he's on Earth, and on the second, he is on Mars. So the acceleration on Earth is 9.8, Mars 3.7. So to find the weight of those weights, we're going to take the mass, 1 kilogram, times gravity for that planet or that Earth or Mars, multiply those together to find the force. So 9.8 newtons. For Mars, 3.7 is our gravity times the 1 kilogram, so 3.7 newtons downward. So when we're looking at net force, we're going to have the summation of force. This is lambda equals symbol, or it means sum of all of our vectors. So the net force is going to be when we add up all the forces acting on an object, what is the resultant? So maybe we're pushing to the left with 10 newtons and to the right with 8 newtons. So the net force would be 2 newtons to the left. And so all of this goes back to our friend Isaac Newton. And so he made these 3 laws of motion in the 17th century. And so we're going to be looking at his laws in the next 3 sections, first, second, and third law.